Hello and good morning to everyone. Our today's lead code question is 1979, which is find greatest common divisor of a array. So basically in this question we are given an integer array nums. Now what we have to do is we have to return the GCD of the smallest number, let's say minimum number of the array, and the largest number, that is the maximum number of the array. So this is what we have to return in the question, right? Now let's see the examples to get the question more clearly. So here this is our nums array, that is we have elements 2, 5, 6, 9 and 10. So which one is the smallest element? So smallest element is 2, that is our minimum element. And which one is the maximum element? So maximum element is 10. So we get our minimum element, we get our maximum element. Now what we have to do is we have to find the GCD of minimum and maximum. So GCD of 2 and 10 is 2. So that is our answer, right? So let's see the constraints. So here in the array we can have 1000 elements, right? We can have 1000 elements, and each element value can be from 1 to 1000, can be from 1 to 1000. So let's see the approach part. So what we thought is, what we do is, first we'll iterate over the array, and then in that iteration we'll find the minimum and maximum of the array. And once we get the minimum and maximum of the array, then we find the GCD of the minimum and maximum and return the value that we get, and that value is our final answer. Now the thing is that how we'll find GCD. So either we can use inbuilt functions, or we can use Euclidean algorithm. So these are the two ways by which we can find the GCD. So first is the inbuilt functions. So in C++ and Python 3 we have the inbuilt function GCD of a comma b, and it will return as the GCD of these two numbers. But in Java we have to use big integer object, and then we have to use GCD function, right? So how it works? So suppose if you have two numbers a and b, right? So first we have to convert both the number a to big integer object, and also number b to big integer object. So now let's say a is big integer object of small a and b is big integer object of small b. Then what we have to do is, then we have to do a dot GCD of b. Now this will give us the answer, but the answer is again in big integer, is again in big integer, right? So we have to convert that answer to integer, right? So for that we have to use int value. So that's why if you see here, big integer dot value of a, so first we have converted a to big integer, then we have converted b to big integer, then what we have done is a dot GCD of big integer value of b, let's say capital B. So this value, this will give us a again a big integer. So to convert that big integer to integer we have used dot int value, right? So this way in Java we can use the inbuilt function. Now the second way is to use the Euclidean algorithm. So what it does is, it instead of checking all the factors of both the numbers, what it does is it will reduce our, it will use a reduction technique, we can say. So what it does is, so suppose we have to find GCD of a comma b, then it reduce that value to GCD of b comma a modulo b. Here modulo, that is basically remainder. So whatever remainder that we get from a and b, that we take here, and then b here. So we use this technique, and then once our b becomes 0, then whatever answer that we have in a, that will be our GCD, right? And this works because when we replace the larger number with the remainder, then that will not change the GCD. So we'll see how that do not change the GCD. So suppose we have two numbers, first number is 36 and second number is 24. So we can write 36 is basically 24 into 1 plus 12. We can write 36 as this way, right? And now any number which divide 36 and 24, which divides 36 and 24 will also divide the also divide 36 minus 24, right? So how? Let's say there is a number d which divides both 36 and 24. So we can write is 36 as a into d is the number that divides, and 24 is b into d, right? So what will be 36 minus 24? 36 minus 24 will be ad minus bd, right? And we can write it as a minus b into d. So here we can see there is a factor d in the subtraction also. So whatever number that divides 36 and 24 will also divide their subtraction value, right? So using this, right, using this, what we'll do is, now suppose if you have to find the GCD of 36 and 24, now instead of taking 36, what we can take, we can take subtraction of 36 minus 24, which is 12, right? Because because if any number that divides both these numbers, that will also divide this number. We have also seen the proof, right? We also seen the proof. So instead of taking bigger numbers, we will try to reduce the numbers. So next will be, we have reduced 36 to, we have taken 12, so it will become GCD of 24 comma 12, right? So this way we will reduce the, this way in the Euclidean algorithm will reduce the bigger number to the smaller numbers, right? So let's see the full way how we'll take it. So we have taken the number 36 and 24. Then what is the remainder? That is 36 modulo 24. So it will give us 12. So we have taken 12. Now instead of taking 36 and 24, we will take 24 and 12 in the next round. So we have taken a will become b and b will become a modulo b, right? So 24 will come here and then this 12 will come here. Then 24 modulo 12, 24 modulo 12 is 0, so now our remainder is 0. So again this 12 will go here and this 0 will here. So what is the stopping condition? When b becomes 0, when b becomes 0, then we have to stop, and at that time whatever value that we have in a, that will be our GCD, that will be our GCD. So GCD of 36 and 24 is 12, right? Now let's see the code of the Euclidean algorithm. So in this this is the iterative approach, or we can say iterative code, and this one is the recursive code. So in recursive code, when our b becomes 0, when our b becomes 0, then at that time whatever value we have of a, that is our GCD, so we return that. Else what we do is, else we call, else instead of GCD of a comma b, we'll call GCD of b comma a modulo b, like whatever we have seen in the example, that same thing we are doing here. Now in the iterative approach, what we'll do is, we'll use a while loop until our b do nots become equal to 0, right? Then we store the value of b in a temporary variable, and then we replace b with a modulo b, and then a with a, we have to assign the value b, and that we have already stored in the temp, so we make a equal to temp, right? And once our b becomes 0, then we return the value of a. So this is a iterative code. Now if you have to see the full code, so for the full code of the question, what we'll do is, we'll use a while loop from I is equal to 0 to size of that loop, and then we check if nums of, and then also we have two variables, minimum which is equal to 1001, and a variable maximum which is equal to 0. Now we check if nums of I is less than minimum. If nums of I is less than minimum, we'll update minimum to nums of I, and then we check if nums of I is greater than maximum, then we update maximum to nums of I. So after this loop, what we'll get? We'll get minimum, we'll get maximum, right? Then we use the function GCD of minimum comma maximum, and then return this value. So I hope I am able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.